So we need to solve a problem of a beam. Okay, today we are going to have a beam. Okay, so for that it comes under static analysis. Okay, static structural analysis. So what we are going to do is we will just drag and drop static structural analysis. Okay, so this is your static structural analysis. Now the next thing we do is we add the materials in it. Okay, so how we do it? Double click this. Okay, once you double click this, the engineering data is going to appear over here. Okay, now this is structural steel. If you don't pick anything, then structural steel is going to be your default material. But if you want to add different material, like the material can be a concrete, a material can be any different material. Okay, it can be of aluminum, all sort of things can be added. Okay, how we can add other materials in it? See, when you go to this filter engineering data, see there are different material can be identified. Okay, just a minute. Okay, so we can add, okay, we can add different material in it. Okay, okay, see, engineering data source. When you click this engineering data source, see different materials are there. Okay, okay, fine. So if you want a different material in it, see there are different materials in it. Okay, so if you want to know the different materials, which are the different, Ansys Granta is a library in which there are different materials are there. Okay, you can pick any sort of materials in it and you can select all sort of materials. Okay, so like this, see, Ansys Granta material library, there is air and gas compositions are there, all sort of things are there, magnesium alloy. Okay, see there are different alloys in it, epoxy fiber also. Okay, so when you need to solve composite type of material, then PCB laminate, this kind of components need materials need to be used. Okay, similarly ABS plastic. Okay, all sort of these materials are available. You need to just pick and drop all sort of these materials. Okay, so let's say this is structural steel, I want stainless steel. Okay, so I can add this material just by clicking this. See, once I do it, once I add this material, it is going to be added in my engineering data. Okay, so once I go to the filter data, if I go to the
Hello,
filter
sir.
data, yes please.
Sir, please accept the request.
Okay, fine. So see, now you can see the two materials have been added to it. Okay, earlier there was a structural steel, now I have stainless steel also. Okay, so if I want to observe the property of a specific material, I need to click this to understand what sort of density it is having, what sort of, see, you can check it over here, density is 7969. Okay, similarly if I click the isotropic elasticity part, see this Young's modulus is 195 e raised to 11. Okay, all sort of things are given over here, and that is inbuilt library. Okay, Poisson ratio is 0.27, bulk modulus value is given, shear modulus value is given. Okay, so if I want to select a specific geometry, okay, if I want to select a specific geometry, then what you need to do, see, when you see this, there is a cross symbol somewhere over here. If you click this structural steel material will not be, that means this is showing suppress. Okay, so this values will not be considered, only stainless steel material will be considered if I go into the project. Okay, so now once the material is decided, then I go to the project and then I go to the geometry. See, on geometry, whenever you go to the geometry, you need to click the right button first. Okay, you need to click the right button. Okay, once you click the right button, an option is going to be appeared over here. Okay, see, again the discovery is getting open, but you can change it. Okay, see, for most of the system is having the same problem. I also don't have a graphic interface which can support this graphic. Okay, so I will just close it. Okay, and I will start the modeling in any other different software. Okay, let me just show you. Okay. Just hold on for a second because the discovery is too big software and that's why it is taking too much time. Okay. Okay. Now you can see, now I am going to select this design modeler geometry. Okay. Design modeler. On this design modeler, we are going to design a cross section, square cross section. Okay. And that I'm going to show you how we can generate any beam and all sort of things. Okay. Okay, fine. So now I'm selecting the XY plane for geometry. See, XY plane. I have clicked this XY plane and then I'm clicking this look at the face. Okay. So now this kind of geometry is visible to me. Okay. Now I need to sketch the geometry on this plane. Okay. So how I'm going to sketch? See, in the sketching. Okay, so in the sketching again, now I'm going to start. I need to freeze the units. Okay, so see, I need to freeze the unit. This is in millimeter, so I will just press it the millimeter. Okay, you need to freeze the units on which you are using. So now my units are in mm, right? And now I'm going to generate the geometry. So suppose I want to make a horizontal beam. Okay, I don't know the length. Okay, I have just drawn it randomly. And then how we are going to define the dimensions? See, when you click the dimensions, okay, when you click the dimensions, now if I take the mouse in it and if I press the left button, see, I can drag and drop the dimension. H1 is the length. See, H1 is showing you the length. So I am giving it the length of 150 mm. So once I press this 150 mm, the length of the geometry, you can see how the geometry length have been generated. The length have been increased, right? Okay, once this is done, the length is already, we have defined the length of the geometry. Okay, and now I need to define the cross section. What is exact shape of the cross section? That needs to be defined. Okay, so how we are going to define the cross section? See, when you go to the tool, okay, once if you generate the sketch, so this sketch is generated. Once you then okay, and now just hold on, cross section. Okay. Now what we will do, we will generate lines from the sketch. So I will pick this line. Okay, we have generated a line, and when now I need to define the cross section of the geometry. Okay. Okay. See, you can see the cross section. What is the cross section of the geometry? Okay. Once you go to the concept, you can see the last part, that is cross section. Okay. Now I am going to define the cross section of the geometry. जो भी वो जो line है, what is the cross section of the geometry? Okay. So the length was 150. Let's say this is 15 breadth, and let's say the height is 10. Okay, so it is more often a rectangular shape, something geometry. Okay, so I'm just freezing this. If I do it and generate, okay, now whatever be the sketch, the geometry or the line, this line is being assigned with the rectangular cross section. Okay, so this is how we generate a line with a square cross section. We have assigned the cross section. See, rectangular cross section is defined to this line. Okay, once this is done, then we go to the model now. Okay, the model is going to open. See here the geometry, what we have done, just we have drawn a line. Okay, so in the model, then we will define other sort of information like what about the loading. Okay, all sort of things we are going to define it over here. Okay. Okay. So now the model is going to appear. See the you can observe this. This is the geometry or the length of the geometry. Okay. And now what I can go is I can okay. So now I need to define this is the line body. I need to assign cross section. See, if I go over here, rectangular cross section has been arrived. Okay, so now I am defining the assignment. Material assignment need to be done. So when I click this, stainless steel material is also being assigned. Now this is geometry is perfect. That means a line element having a rectangular cross section. So see, now once I define the line element is having a rectangular body, and once I define the material which is having, that is stainless steel, now you can observe the geometry shape. Right now it is perfectly a rectangular shape in which I was expecting my body should be. Okay, and now I need to define the boundary condition. We start any